Let me ask you something that sounds simple and isn't. What actually keeps you alive out here on Earth? Most people would say the sun, and they'd be right, but not for the reason they think. It isn't the sun's size, and it isn't really even its gravity. It's one specific, almost boring thing, the exact, steady amount of light it pours out and has poured out for 4.5 billion years. To see how precious that dull little fact is, let's do something reckless. Let's rip the sun out of the sky and drop a different star into its place and watch what happens to us. We'll try 5 of them. Almost none of them end well. First, the one rule that governs all of this. A star holds Earth in orbit with its gravity, and gravity depends only on mass. So as long as the star we drop in weighs the same as the sun, Earth keeps circling exactly where it does now, at the same distance, in the same year. That part never changes. What changes is everything pouring off the star's surface, the light, the heat, the radiation. And it turns out Earth sits in a shockingly narrow band of comfort. A little more, and we cook. A little less, and we freeze. So keep your eye on that, because we're about to leave the comfortable zone in both directions. Start small. Swap the sun for a red dwarf, the most common kind of star in the whole galaxy, dim and red, and enormously long-lived. Same mass near enough, so our orbit holds. But a red dwarf can shine less than 1/100th as brightly as the sun. At our distance, the sky would dim to a deep, sullen red twilight, and the temperature would collapse. The oceans would freeze from the top down, the air itself would eventually begin to snow, and Earth would become a ball of ice drifting around a dull ember. To have any hope, we'd have needed to be huddled 10 times closer in. Out here, we just go dark and cold. So brighter, then. Let's drop in Sirius, the brightest star in our night sky, about 25 times more luminous than the sun. Now the problem flips over completely. At our same old distance, Earth is flooded with far too much energy. The oceans don't freeze, they boil. The comfortable zone around Sirius sits way out, 5 times farther than we are, past the asteroid belt, and we are nowhere near it. Earth becomes a steaming, sterilized rock. And there's a crueler catch: big bright stars burn out fast. Sirius will live only a small fraction, as long as the sun. Even if Earth could somehow cope, it wouldn't be given the time. And Sirius is nothing. Go really big. A blue supergiant can blaze 100,000 times brighter than the sun. Now the comfortable zone is more than 300 times farther out than Earth. And here, this close, the ground doesn't just warm up, it's scoured by ultraviolet and hammered by radiation. Earth's whole atmosphere would boil off into space, and the planet would be stripped to bare, glowing rock, in stretches of time far too short for life to have ever even started. A blue giant isn't a home. It's an execution. Now the strange ones. Forget brightness. Swap the sun for a neutron star, the ultra-dense corpse of a dead star, the same mass as the sun crushed down into a ball maybe 20 kilometers across, the size of a city. Our orbit, once again, holds perfectly. But a neutron star gives off almost no warmth we could ever use, only a thin and deadly trickle of X-rays. Earth freezes, bathed in radiation, circling a point of darkness the size of a town. And the black hole, everyone's favorite fear. The surprise is that if you replaced the Sun with a black hole of exactly the same mass, Earth would not get sucked in. Nothing would. Our orbit wouldn't shift an inch because the mass is identical. The black hole would be a sphere just a few kilometers wide, sitting silently where the Sun used to be, and the only thing that kills us is the thing that's now missing. The light. The sky goes black, and within days the world begins to freeze solid. No spaghetti, no being torn apart. Just the lights going out. And then, for the finale, the most absurd swap of them all. Let's drop in Betelgeuse, the red giant on the shoulder of Orion, a star so vast that if you placed it where the Sun is, its surface wouldn't stop at Mercury or at Venus or even at us. It would swallow all of them, and Mars too, and reach nearly out to Jupiter. There's no question of what happens to Earth here, because Earth is now somewhere deep inside the star. We wouldn't orbit Betelgeuse. We'd be a faint memory in its outer atmosphere. So we tried 5 stars, and we froze, we boiled, we got irradiated, we went dark, and we got swallowed whole. Which brings us right back to where we started, and to something genuinely worth sitting with. The Sun is not special because it's big or bright or dramatic. Out of the entire zoo of stars in the galaxy, most of them would make far worse neighbors than you would ever want to meet. What makes our star a quiet miracle is the exact thing that makes it boring. It is almost perfectly average and almost perfectly steady, and it has held that steadiness for the billions of years life needed to crawl up out of the sea and eventually build a creature that could sit here imagining swapping it out. We don't orbit the biggest star or the brightest one. We orbit the one that leaves us alone. And that, it turns out, is the rarest gift a star can give.